Hey, how's everybody doing out there? AP Calculus. Good afternoon, Thursday afternoon. Every Thursday afternoon in the spring, what is your favorite pastime? Is it perhaps going outside flying a kite? No. Is it perhaps blinking on and off? No. It is watching AP Calculus, preparing for your AP Calculus exam, which is in how many days? It is in 77. Double 7, George Mirasan. That is 77 divided by 11 weeks. 11 weeks. It'll be here before you even know it. And today, yes, today, we are going to go over problems that will prepare you, the viewer, the calculus student, for the AP exam. Isn't that exciting? You couldn't ask for anything more exciting. Please call on in, 972-925-3123. Hello? Hello? Okay. Can you hear me?
Yeah.
Can you see me?
Yeah.
Is this Angel Acosta?
Uh-huh.
How's it going?
Nothing much. Just here.
Just hanging out, doing a little math?
Yeah.
With your favorite teacher?
Oh, she's not here today.
She's not there today?
No.
Where is she?
I don't know. She went to some meeting.
Some meeting? What is that? AP Calculus, man. Jaguars.
Yeah.
Okay, all right, Angel, here you go. See if you can do this one right here.
Is that to 3/4?
Yeah, that's 3/4.
So we're going to take it there, so you have to bring it down first?
Bring it down, bring it down. No bumping up today. What's the derivative?
And then we have to take the derivative from the inside.
So what are we writing?
Times 2x.
Times 2x, okay? That's the derivative, so h prime of x is going to be equal, or I'm sorry, h prime of 2 would be equal to what? How would you do it without a graphing calculator?
We just plug in the 2 where we see an x.
Okay, so it's 3/4 times 0 to the negative 1/4 times 4, right?
Yes.
So what's the correct answer?
The answer is 4.
The answer is 4, that's right, because it's 0 times 4. Wait a minute, 0 times 4.
Well, 0 times 4 is just 0 then.
It's going to be 0, right?
Yeah, I thought it was plus.
Hey, Angel, let's do it on the calculator. Let's say you had this problem, and let's pretend this was a lot harder to do. And let's do it on the graphing calculator. So we're going to type in, we'll type in parentheses x squared, just a refresher, even though I know you know how to do it, raised to the, I'll go 0.75 plus 1. And if you want to see what the graph looks like, you could just press, that's interesting. So now if we go, if we try to find the derivative,
Which is 7.
it's 0. We're going to get, I thought we had that. Hold on, second trig. The derivative at 0, it doesn't give us an answer. What's going on? What's going
So
on?
it doesn't exist, or?
Yeah, it does. It's right. This is a misleading problem. We'll go back to the problem. This is a pretty hard problem. And I don't think that it'd be this tricky on the AP exam, because you would just go through something like this. But the domain for this problem, is x is greater than or equal to 2, or x is less than or equal to negative 2. Because if you plug in like 0, you get negative 4 to the 3/4, and you can't do that because you can't take the 4th root of a negative number. You know what I'm talking about?
Yeah.
So you would go through it like this, but the correct answer really is that since it's not continuous there, it's not differentiable there, so you really could not find the answer. But on the AP exam, your first instinct was right. You'd go through that.
All right.
Isn't that exciting?
Huh?
Isn't that exciting, Angel?
Yeah.
Hey, I think it is. All right. Hey, great job.
All right.
Annalisa,
Yes.
I got your picture.
Do you?
Yes, it's a very nice picture.
Thank you.
You're welcome. We're going to show you right there. There we go. There you are! Over the camera!
He framed it. It's all been on.
I thought your picture was going to be stuck on the monitor. And that would be, I'm going to give you a hard problem.
Oh, good.
Okay? Oh, good. That's good. Because, I think you're tired of those easy problems.
Uh-huh.
You know what I mean?
Yeah. We really are. Miss Arthur says we are.
I heard, I just heard your mother's babysitter talk.
Mm-hmm.
Yeah. So, okay, Annalisa,
Mm-hmm.
this says, no help from Mrs. Arthur back there. F of
Who?
x is equal to 6x divided by a plus x, for which f prime of 0 is equal to 3. If a doesn't equal 0, then what must a be?
Okay, hold on. Okay. Do you want me to tell you, what to do?
What's that?
Do you want me to tell you what to do?
Yeah, tell me what to do. You always tell me what to do anyway, so go ahead.
Derive it.
Okay, and what's the derivative of this puppy?
Okay, hold on. You put the little a plus x to the top, right?
Okay.
X, a plus x to negative 1 times 6x.
Times what?
Oh, times 6.
Okay. Excellent.
Oh.
Excellent.
And then minus, let's see, ho first. Hold on.
Ho-
Be quiet.
Hody high minus.
Yeah, ho. So your high is your 6x times 1.
Times 1, okay, which we'll just leave it as 6x. All divided by?
A plus x squared.
Okay, I like this problem. This is a good problem. This is like a medium hard AP problem. A medium hard multiple choice. Now, okay, so this tells us what the derivative is, but how can we find a? If f prime of 0 is equal to 3, how can we find a?
Hold on.
Okay, I will.
Shouldn't we distribute our 6 first?
We can if you would like. This problem may be on your AP exam.
Well, then I'll just be so much more prepared.
You know what? That's what I'm thinking, Annalisa. So if you distribute the 6a, well, that makes it a little easier. So it's 6a over a plus x quantity squared, okay?
So then, if f prime of x is 0,
It
then
says f prime of 0 is equal, it says
Oh.
f prime of 0 is 3.
same difference. So then,
Oh, not really.
wouldn't you plug in your 0 for your x,
Okay, plug in 0 for x.
and that has to equal 3?
Very good. So it'd be 6a over a squared, right? Because 0. So what does 6a over a squared simplify to?
6 over a.
Okay, and then what would the answer be? 3 is equal 6 divided by what?
2.
A fine job!
Thank you.
You could
Miss
cross-
Arthur didn't even help me very much.
You know what, Annalisa?
Huh.
That was really a hard problem too. A medium hard problem on the AP exam. Don't you feel pretty good about that?
Wonderful.
Hey, that's what I'm thinking. Hey, make sure you call in again, okay?
Uh-huh.
All right.
Bye.
Butters!
Hey, how you doing?
Fine butters. Like you're smooth as butter. 11%. 11 grams. You know what? Do you know what that means?
I think I do. They explain it to me.
I don't really know what it means. So,
Okay.
but you're butters, so I gotta give you a hard problem.
No,
Okay.
don't.
Oh yes! Oh yes!
all day
Oh
yesterday,
no! What?
I did calculus problems all day yesterday.
Well, that's good for you. It's healthy.
No. Oh, you know what? I got a 5 on my multiple choice.
5 on your multiple choice.
Yeah, Miss Harmon said, you know the percentage thing is, she said I'm going to get a 5.
Wow. Only if you get this problem right, Butters.
No, please don't.
It's okay. It's all right. Butters. 11 grams of fat. That's it. Per serving.
Yeah.
Okay. All right. It's a tough problem.
Could you, like, write it like really big.
How's that?
Okay, you want me to take, integrate that?
Yeah.
Okay,
That's what that means.
How about we do the u thingy first?
Let's do the u thing
Okay,
first.
u equals to 1 plus e to the x. So du is e to the x.
Okay, so du is equal to e to the x. Good.
Yeah,
I'm switching-
dx. So we have the little ex sitting there. Dx, see, e to the x, dx, so that's our du.
All right, so that's du,
So all
right?
we have is u to the 1/2.
Okay.
And then when you integrate that,
So we have u to the 1/2.
u to the 1/2, right.
Okay.
And then you have u,
All right, keep going.
should we like put the natural log of n into the u equation?
Okay, so you want to change your limits.
Yes.
Okay, and so in this limit, in terms of
Plug it
u,
in.
it would be 1 plus e to the natural log of 3,
Which is 3.
which is
1
1 plus 3, which is 4.
4.
Okay. Butters, this is impressive. Impressive, Butters.
Okay, plug in the other one.
All right.
So 1 plus 8 is 9.
Butters. Okay, keep going.
Okay, now integrate that. You have u to the 3/2 times 2/3.
Okay.
And then just plug in 9 plugins and then plug in 9,
Okay.
which is 3 to the 3rd is 27.
So 3 to the 3/2 is 27, so that's 18, right? 2/3,
Right.
all right?
18 minus square root of 4 is 2 to the 3rd is 8. 8 times 2 is 16 divided by 3 is something like that.
So 18 on the AP exam, you'd be able to leave your answer like that if it's free response, but
Yeah.
otherwise we can make it 54 over 3.
Yeah, make a little common denominator.
Yeah,
and
so the
everything.
answer would be 38 over 3.
Okay.
Yeah, it is very good. And if you could do it on your if you had your graphing calculator, it'd be a lot easier to do, right?
Yeah.
But that is a fine job. You know what? You get a bell. That was a hard problem too.
Thank you.
Don't you think?
Uh-huh.
That was really good. Hey, next time you call in, Butters, I'll be waiting for you. I'm ready for you.
Oh, I might call in today again.
You better call in today. I got a problem for you, okay?
Okay.
All right. Good
Bye.
job. Who's out there?
Hi.
Who's that?
This is Ann.
Is this Ann Eckenrode?
Quiet.
How you doing?
Good. How are you?
I'm fine. Thank you for asking. Here you go. You ready?
Yeah.
Let's do a little particle problem.
Oh my gosh.
Oh my goodness.
Okay, a particle. Okay.
Particle moves along the x-axis in such a way that its acceleration, it's 5 over t squared.
Okay, first of all, I would rewrite AFT to so that AFT equals 5 to the negative 5t to the negative 2.
Okay, 5t to the negative 2. Keep going. Fine job. Fine job.
Okay, and then then I would, since I want velocity, and I would integrate AFT.
Okay, and what do you get?
Just a second, let me work it out, okay?
Okay.
Okay, 5t to negative 2, you bump it up.
Bump it up, baby. Bump it up. So it's you bump it up and you get 5t.
To negative 1 over negative 1, which if you rewrite it would be negative 5 over t. And then
Don't forget the plus c, yeah.
Plus c, of course. Okay, now it says, so on the velocity equation, 1, 3 is a point, so so 3 equals negative 5, yeah. Yeah.
That's right. I heard you say it. You said 3 is the velocity and 1 at t equals 1. So you get c is equal to 8.
Right. You're going a little fast, sorry.
You're going too fast. You're the one who solved it.
Okay, c equals 8, so, just let me write down the v of t, okay?
Right. Okay.
Thank you.
Okay. Hey, Ann, that's an excellent job. This was
That's all you want. No,
that's Angel Acosta.
Angel.
I know. They called it. That was the first caller. Hey, Ann, fine job, Ann. That is a fine job.
You're welcome.
All right, good job.
You,
Is this Kyle Reagan?
It is.
I'm ready for you. You ready?
Oh, really?
Uh-huh.
All right.
I'm ready for you, big guy.
Okay.
You know, you're talking trash. You're talking calculus
Bring it
trash.
on, Fleischer.
What?
Bring it on.
Bring it on, the man says. Okay. I got 2 problems for you.
Okay.
Okay. This is Kyle is a BC student, but this is AB.
Okay.
Well, hold on.
Oh, okay. Let me get some paper out.
Okay, I got problem number 1 and problem number 2.
Well,
Which
one-
problem would you like to try to solve first?
First of all, on number 2.
To get the bell, you have to solve both of them.
Okay.
All right.
Trying to. Okay. First of all, on the second one, I do believe that 1 plus tangent squared is secant squared.
Okay.
And so all you've got is secant to the -3.
Okay.
So
So
on
what
the
Kyle
second
is
one.
saying is that this is just secant squared or secant squared, which is secant.
Uh-huh.
So this is just d theta over secant cubed.
Secant cubed is nothing but 1 over cosine. And so you've
Like
got
cosine, it's cosine.
cosine, cosine, it's the same thing. Anyway.
Okay.
And the integral of cosine cubed, you take one of the cosines out and you transform the other one into 1 over sine squared. And
Okay, so this translates to cosine cubed. So how do you want me to rewrite it?
you make cosine squared into 1 minus sine squared, and you factor the other cosine in. And so
Okay.
you've got cosine, yeah.
That's the only way you can integrate cosine cubed, right? If
Exactly.
you say cosine again, you don't get a bell. It's cosine. I'm just teasing you.
Well, I'm going to keep saying cosine, so
I
know.
figured you would. Okay, and then how do you integrate? Now this is AB right here. You should know how to integrate this.
yeah, that's just ends up
For your-
sine of x.
Sine, the integral of cosine is sine.
Yeah,
A
and
theta.
that would be a third of sine cubed.
Whoa, is it plus or minus?
It would be minus because of the negative sign you already have. Yeah. Because the derivative,
Take your time.
interderivative,
Take your time.
interderivative of sine is cosine.
Is
And-
it plus or minus?
It's minus.
You sure?
Yes.
You're right. Okay. What he did
Oh,
was
you're evil.
he said u is equal to sine of theta du.
No, I didn't say anything
Well,
about
I know,
you.
but for the people he was doing in his head, du is cosine theta. So he has this is just the integral of u squared du. It's the integral of u squared du, which is u cubed over 3, which is 1/3 u cubed or 1/3 sine of theta cubed. Okay, plus c.
Yep.
Fine job on that one. Okay, number 1 in
Okay.
order to get the bell.
Number 1, 1 minus tangent squared,
Yes, sir.
that would be,
This is cosine squared, d theta over cosine squared times square root of 1 minus tangent squared theta.
that would be, don't you mean,
I don't, this is what I mean. I know what I mean. Don't try to stall.
okay, you changed it to 1 minus tangent squared.
How about, would you like to have a few, to think about it and call in about 10, 15 minutes?
Well, no, I
To be
don't
honest
think
with
so.
you, okay, you want to try to do it now?
Yeah, because
Okay.
isn't 1 minus tangent squared,
It's no, isn't it what?
isn't it cosine squared minus sine squared?
No, I don't think so. It's, it would be cosine squared minus sine squared divided by cosine
Yeah,
squared. So
Well,
it'd be
because
square
you've
root, square root of cosine squared minus sine squared divided
over
by
sine squared.
I'll tell you what, why don't, call back again, seriously.
I'll work on it.
Work on it.
And-
See, you still get a bell if you can get it, all right?
Fleischer, I've got a problem for you.
Okay, all right. You bring that next time. If you get
Okay.
this one right, you can bring it out.
Okay.
Christy!
Yeah,
How
hey.
you doing?
Fine, how are you?
I'm fine. Are you calling from WT White?
No, I'm calling from Brian Adams.
They told me it was this Christy Knapp. They told me it's Christy from WT White.
No, it's Christy from Brian Adams.
It's Christy Knapp. How
Yeah.
you doing?
Fine, how are you?
I'm fine. Thanks for asking.
You already asked that.
Hey, you know, I don't need any help from Miss Arthur. that's not nice. But tell her that. I don't know. Tell her something though. Hey, Christy, because Miss Arthur was mean, you get a little harder problem.
Oh man.
But you can do this. We'll give her some inspiration. We'll give you some inspiration for her to do that. Can you see that? Okay.
Yeah.
Okay.
Okay. Okay. U is going to be. Golly. U is going to be 1 plus x squared.
Okay. U is going to be equal to 1 plus x squared. All right.
D of U is 2x d of x.
Du is equal to 2x dx. All right.
So you're going to have to multiply the outside by 2.
All right. So what do you want me to write down?
Okay, 2 times the integral from 0 to square root of 3.
Okay.
Du over u.
Okay.
And so.
Hey, Christy, you know, it really is 0 to square root of 3 in terms of x. Just be careful. Be careful about writing these limits if you have a u here. But go ahead, just finish the problem. I'll explain what I'm talking about later. It's
Okay.
just, I mean, the reason you're right. You're going to get the answer right. I'm just worried that, like something on the AP exam, that they would take off for something like that. They haven't had a problem like that on the free response, but they might one day. But go ahead.
Okay, so then it's going to be 2 times the natural log of u.
Okay.
Wait, never mind. Okay, so it's 2 times the natural log of 1 plus x squared.
Okay. And now you could do it from 0 to square root of 3. And see, what you could have done, did Miss Arthur show you how to change these limits if you wanted to?
No.
Okay. Okay. Never mind. I understand. So we don't want to confuse you anymore. I'm not even going to bring it up then. So you did it right. You did it perfect. So it's 2 natural log of 1 plus 3, which is 4, minus 2 natural log of 1. What's natural log of 1?
0.
It's 0, right. And so answer would just be 2 natural log of 4 or natural log of 16. Why can I say 2 natural log of 4 or natural log of 16? Why is that?
Because it's the same as the natural log of 4 squared.
Fine job, Christy Knapp.
Thank you.
No, thank you. Thank you for calling in.
Bye.
Hey, bye. Mustafa!
Yes, hello, how you doing?
What school?
Townview.
Townview.
Yes.
With, who's your teacher?
Mr. Howell.
The great Mr. Howell?
Yes, sir.
How you doing, Mustafa?
I'm sorry.
How are you doing?
I'm fine, how are you?
I'm fine. What's your last name?
Jen.
How do you spell it?
D-I-E-N-G.
All right. You ready for a good problem?
Yes, sir.
Okay, here you go. What'd you do in class today?
I didn't have him today.
What'd you do in class yesterday?
We worked on our reviews and substituting antiderivatives and
Okay, here you go. Here's the problem.
stuff. Okay. Okay. My u would be x squared, am I right?
U would be equal to x squared. Excellent, Mustafa. Excellent.
Okay. So du would be 2x dx.
Okay.
Okay.
2x
So I would
dx.
have x sine of u
So it's x sine of u.
dx, and I'll have like a 1/2 in front of it. Am I right?
Right. Okay.
Okay.
See, I think what you're doing, and you're doing it right. You said
Yeah.
you had the. If you solve for dx, I always like doing it this way. A lot of teachers teach it differently, and the students are successful. But this is the way I like to do it.
Okay.
I saw, which is just what you did.
Okay.
It's like the x's cancel out, and you got 1/2 times the integral of sine of u du.
There you go.
So, and what's the integral of sine of u?
Would be negative cosine.
Excellent. So it's negative 1/2 cosine of u, or cosine of x squared plus c. How could you check your answer, Mustafa?
By finding the derivatives of that.
That's right. Find the derivative, and it'll come out to be exactly that, right?
All right.
Mustafa, I need a picture, Mustafa.
Sure, you have one. I'll send you one.
Hey, give it to Mr. Howell, and we'll get it to us, okay?
No problem.
Hey, fine job, Mustafa.
Thank you.
See you later. Rocio!
Hey, what's up?
Hey, no, what's going on?
Huh?
Are you ready to bump it up and divide?
Sure.
Okay, sure. Jaguars. Where's your teacher? So you all showed up without your teacher?
No, she wasn't. She's in a convention or something.
A convention or something?
Yeah.
Home, she had to write essays.
Yep.
What?
For Teacher of the Year essays. She had to stay home to write Teacher of the Year essays.
Oh, Teacher of the Year essay. So basically, she's skipping class to do her homework, right?
Yes.
All right, I got you. That's pretty impressive. Pretty impressive. Okay, Rocio.
Mhm.
It's a little bit harder than it looks, or maybe easier than it looks. I can't tell.
Okay. Okay. The U, or U substitution, equals
Okay.
natural log of x.
How do you know that so quickly? Seriously. Because you're Jaguar. No, but seriously, Rocio, how do you know that so quickly?
Because there's no way. Well, natural log of x is 1 over x, and that's the only thing to get 1 over x.
Well, that's very impressive. I mean, that's
Well, we're the Jaguars.
Jaguar.
Okay. Du.
There she is, Rocio! Okay. Rocio basketball. Okay, so basically, u is equal natural log of x, du is equal 1 over x,
Dx.
dx. That's excellent. So what do you want to do from here?
Okay, it's gonna be integrating from 1 over x, isn't it? No. 1 over u.
Right, it's 1 over u.
Du.
It's right, just 1 over u times du, right? And
Mhm.
what's the answer to that?
And then that's natural log of absolute of u.
Natural log of u or natural log of absolute value of u, so it's
Plus
natural
c.
log and natural log of x.
Let's see.
Right? Wow, that is too... You know, call it again. I'm going to give you a harder problem. That's,
All right.
right,
Be waiting.
bring it on.
Bye.
Bring it on. Kyle, you figured it out?
Okay.
All right, hold
Now-
on. Well, let me find the problem. Hold on.
All right.
Okay. Now, did you get any help?
Miss Bradford is confused, but no real help.
Okay, I hope I did it right. Okay.
Now, since you've got 1 minus tangent squared,
Uh-huh.
I'm going to say that tangent squared is sine squared over cosine squared, and I'm going to make the inside of that square root, I'm going to make it cosine squared minus sine squared all over cosine squared.
Okay.
Okay? Then I'm going to square root that bottom cosine squared.
Okay, so, I know what you're doing. Go ahead.
Okay.
I don't know where you're going to get the right answer from this, but go ahead.
Now, you've got a cosine squared outside that radical, correct?
So, right.
So it cancels with one of those.
Right, so what you're saying is you somehow simplified this to be d theta times cosine theta times square root of cosine squared minus sine squared.
Uh-huh. You want to know where I went with it next?
Okay, what'd you do then?
I did a trig sub of trig functions.
Okay, look, can I show you an easier way to do this problem?
Go ahead.
This is an AB problem. This is an AB problem. This secant squared theta. I don't know if the AB teachers have covered this yet, but this is all over 1 minus.
Oh.
So now you just have, this is just,
derivative of tangent squared is
so this is just the integral of du
Oh.
all over square root of 1 minus u squared, which is just the inverse sine of u.
You are amazing, Fleischer.
I told you I'd get you.
Yeah, okay, hey, I got a problem for you.
Okay, all right, hold on, let me write it down here.
All right.
I'll do it, I won't do it because there's a lot of callers, but I'll show you how to do it. Go ahead.
You'll probably get it. It's the limit as x approaches 0
Yeah, limits, all right, go ahead.
of parentheses 1 plus 1 over x in parentheses raised to 1 over cosecant x power.
Cosecant x? Okay, well, my first instinct is this is just e because it's 1 plus 0.
You're a jerk.
Okay, so the answer would just be e.
Yeah.
All right, anyway, but that's a BC problem. So
See you later, Superfly.
Hey, all right, I'm gonna get you next week too, Kyle.
Okay.
Call in again. All right,
Okay.
good job.
Hello.
Annie,
Oh, hi.
how you doing?
I'm fine.
Are you nervous?
Yes.
I'm nervous too. We're both nervous. Ah! That was sort of silly. Okay, anyway, I got to give you a hard problem then.
No, don't give me a hard problem.
Why not?
No.
No, I won't give you a hard problem.
Okay.
Annie, what's your last name?
Chao, Tchao.
This problem's too easy for you then, but that's okay. Hey, Annie, did you take the practice test?
For BC, yes.
For BC.
But give me AB, don't give me
I'm
BC.
giving you AB.
Okay.
Okay. I'm giving you AB.
X squared plus 2x. Okay.
This is an AB problem.
Okay,
Hopefully
can I get x squared over 4x? Can you separate all of those?
So what do you want me to rewrite?
X squared plus 4x plus,
X squared plus 4x?
yes. I mean over 4x, sorry.
Okay.
Alright, plus 1/2
Okay.
plus 1 over 2x.
This problem's too easy for you.
No, it
But I'm going to
isn't.
ask you a really good question in a second.
Okay.
Okay, I'm going to ask you a really good question in a second that even Bhumika Kapadia might be able to do. Go ahead.
Okay.
What do we do from here?
We integrate x squared. U equal x, 2x.
Well, how do you integrate this?
Okay, we can cancel the x first.
Yeah, cancel it. Make it
Sorry.
1/4 x.
Uh-huh.
Okay, and the integral of 1/4 x, well, I'll rewrite this. Plus
That'd be x squared over 1 over 8.
x squared over
Over
8.
8, yes.
Okay.
Plus 1/2 x.
Okay. And what's the integral of that?
Wait, oh, you take the 1/2 out of the natural log, so 1/2 natural log of x.
So you move the 1/2 out.
Yes.
Okay, and that leads, and what you did, Annie, you moved it out, so it's just 1/2 natural log of x, okay?
Yes.
Plus c. I got a great question for you. Ready?
Okay.
Okay, and you probably won't be able to get it right away, but see if you can think about it and maybe call in again later today. Let's take a look at this integral. Okay? This is hard. This will be fun for your teachers too.
Okay.
If you take a look at this, what you did was you made it 1/2 times the integral of 1 over x, right?
Yes.
Which is equal to 1/2 times natural log of x plus c, right?
Yes.
But there's another way you could have done the problem. You could have set u equal to 2x, du equal to 2 dx. So the way I thought dx is equal to du, you guys don't do that step, but I do. So it's 1/2 times the integral of natural log of u du. I'm sorry, 1/2. I skipped a step.
Wait.
1/2 times the integral of du over u. You see that?
Yes,
Which
that's right.
is 1/2 natural log of u,
Isn't that the same?
which is 1/2 natural log of 2x.
2x?
Wait a minute
Huh.
here. How is that possible? These are two different functions. These are totally two different. 1/2 natural log of x and 1/2 natural log of 2x are two totally separate deals. This is a legitimate way to do the problem.
That is?
And so is this. I'm going to give you a hint and see if anybody can get it. The hint is both answers are correct. How is that possible? All right? So you
Okay.
figure that out and call in again, okay?
Okay.
Good job, Annie.
Thank you, bye.
Bhumika Kapadia!
Hi.
Hi. Yeah, how come I don't have a picture?
Remember you stole one last year from Miss Arthur and you never put it up?
Well, it's,
You lost it.
I didn't lose it. Delbert Richardson.
Who's that?
Delbert says he has it at his desk and he'll bring it next week.
Okay.
I'm going to give a problem here.
We want to know when you're coming to our school.
When I'm
fifth
coming
period.
to your school,
5th period. 5th!
5th period.
Yeah. 5th!
Soon. Soon. I don't know, but I'll try. I'll certainly be there at the prep sessions. Are you going to be there at the prep sessions? That's right. Okay, here we go. This is integral of e to the 2x over 4 plus e to the 2x.
E to the 2x over 4 plus e to the 2x.
Correct.
It's a natural log.
Hey, let me ask you something. Bhumika Kapadia.
Okay.
How come your first instinct is not to set u equal to 2x?
I don't know. Because we're real smart over here.
Because you're real smart. I understand. But you know what? here's the little secret, the key. Whenever you have an integral, if there's just one e in the integral, 90% of the time, 95% of the time, you're going to set u equal to the exponent. If there's more than one e, most of the time you're not going to set u equal to the exponent. All right? You know what I mean? Here, there's two e's there.
Right.
Okay? Bhumika Kapadia has 0 e's. All right. Anyway, so what do you do here, Bhumika?
Okay, you're going to have, you assign e to the bottom, 4 plus e to the 2x.
All right.
And then you're going to have e to the 2x times 2.
Okay, and what do I do there from there?
You're going to cancel out, so you're going to be left with the 1/2 integral from 1 over u.
So it's du over u, right?
Right.
Okay, and then that's just 1/2 natural log of u,
Right.
or 4 plus e to 2x. Hey, why don't I need absolute values here?
Because it's positive, because it's a 2.
Yeah, because 4 plus e to the anything is always positive. 4 plus that will always be positive. So therefore, you don't need absolute values. It would be superfluous. It would be redundant. It would be repetitive. Can you think of another word? Quick, Bhumika, quick. Come on, let's have a word play. Extra. Ha! Got you.
Ah!
Okay. Hey, good job.
Okay.
Call it again, all right?
Okay.
I had fun. Nina?
Yeah.
Nina from Molina! That could be a song. Is Karina from Molina there?
Yeah.
Karina and Nina from Molina. Are there any other Inas?
No.
No more Inas?
No.
Okay, how you doing?
Fine.
You know, I'm running out of problems for you Jaguars. Because, do you want to see your picture?
You don't have one.
That's what you think.
No, I don't want to see it.
Okay, I'm going to give you a philosophical problem. All right? Philosophical. You ready? Hopefully you can read this. You ready? You ready? Ready? Winning the war against poverty has been described cynically as slowing the rate at which people are slipping below the poverty line. Assuming this is happening, sketch a graph of the total number of people in poverty against time. Well, we don't have to worry about that. But if the number of n represents the number of people below the line at time t, what are the signs of dn dt and the second derivative with respect to t? What are the signs, meaning are they positive or negative?
Positive.
Hey, let's tell me if it's been described as slowing the rate at which people are slipping below the poverty line. With the graph, I'm going to draw a couple graphs and you tell me. As time goes on, let's assume this is the poverty line. Okay. As time goes on, is the graph going to look like this? Is that possible?
No.
Is the graph going to look like this?
He said it was slowing, right?
What do you think the graph would look like?
The second one.
You think it looked like the second one?
That's what everybody told me.
Well, let's think about this. So what's happening? More people.
Next problem.
Next problem. You don't want to do this problem?
Nobody gets it.
Nobody gets it? Well, wait, hold on. Give me a second here. I'm going to try to explain it. Slowing the rate at which people are slipping below the poverty line. So that means more people are still becoming poor, but yet it's less than the previous year. For example, this means, let's say in 1998, 10,000 people were slipped below the poverty line. In 1999, only 15,000 people were below the poverty line, and in 2000, maybe 17,000 people were below the poverty line. So it's increasing.
I hope so.
The fact that the number of people who are becoming povered, the number of people who are becoming poor are increasing, but it's at a decreasing rate. So if it's increasing and at a decreasing rate, then it would look more like this graph, where the number of people is increasing. The number, forget about this line, but the number of people is increasing, yet it's increasing at a decreasing rate. So if the graph did look like this, if it looked like this, and this is, the y-axis is number of people who are below the poverty line, and y is the people, or x is the people. If the graph looked like this, what would the sign of, this is time and this is n, this is the number, what would the sign of dn dt be and the second derivative be? What if this is n is the y-axis and t is the x-axis? If the graph does look like this, in other words, the number of people are increasing, but not increasing as much as they increase. What do you think? What do you think, Nina? If this is the graph? What's the sign of dn dt? Do you want to skip it? Hello?
They said positive because
It's positive. What about the sign of the second derivative?
negative.
It's negative, right? The slope is positive and the concavity is negative, right? So if you try to look at this, try to understand this as far as the number of people are increasing, but at a decreasing rate. Now that I totally confused you, I'll give you a better problem next time, okay?
Okay.
All right. Hello? Miranda?
Hey, Mr. Fleischer.
Is this Miranda Bailey?
Yeah,
How you doing?
good.
Are your TVs working at Carter?
Yeah, TV's working.
Is Miss Blackwell working you hard?
Too hard.
It's never too hard, Miranda. Never too hard.
it's
Where is
always too
Kara
hard.
there with you?
Nuh-uh, Carol at track practice.
Track practice. She needs to run to do some calculus. Hey, what'd you guys do today in class?
What we do, Miss Blackwell? we took a bit. Oh, we went over lesson 5.5.
Oh, 5.5. Okay, I'll give you a problem.
No.
No. Hey, it's all right. Trust me.
It was hard.
Trust me. I'm
Let's
gonna
go
give you a
back
problem
to
on
5.4.
5.4. All right, I'm not gonna hurt you. I won't hurt you.
Okay.
Real quickly, tell me the derivative.
The derivative of that is cosine e to the sine x.
Right. Very good. Excellent, Miranda. Excellent. So, okay, tell me this problem. Tell me the answer to this one. You ready?
I guess.
You get it.
You gotta put a 1/2 on the outside.
Man, she is Miranda Bailey, ladies and gentlemen. I need pictures. I don't have pictures
The
of Carter
answer-
students. Go ahead.
The answer is. Oh, okay. You fixed it. You gotta put a 2 in front of the x.
So what do you want me to put?
A 2 in front of the x, so you can fix it.
Okay, 2 in front of the x, so I fix it. I'm looking for another color marker. Okay, 2 in front of the x.
I'm not gonna use the u substitution.
Okay. So if you put a 2 in 1/2, same thing. Okay, what am I doing? Okay, tell me what to write.
Okay, the answer is 1/2 e to the x squared.
You know,
C.
Miranda, that is excellent. You know, sometimes u substitution can just confuse what you already instinctively know how to do, right?
Right.
Because you know how to take the derivative of this, and you know that's so. If you take the derivative, you know that it matches the integral. You could have done u is equal x squared, and you come up with the same answer. But that is fantastic, Miranda. That's fantastic. That really is. You gonna come to those prep sessions in the spring?
Yep.
Hey, tell the Carter students to get pictures of Miss Blackwell so I can put them on TV, okay?
Okay.
All right. Hey, great job. Call in again.
Thank you.
Carter Cowboys. Alan DeBard,
Hey, Mr. Fleischer.
what's going on, dude?
Not much. How you been?
I'm fine. Thanks for asking. I've been fine.
That's good.
How have you been?
I'm doing good.
Harvard still?
No, I decided to turn them down. I wasn't interested going there, so.
Where are you gonna go?
Washington Lee.
Hey, that's fine. Is that in Virginia?
Lexington, Virginia, yeah.
Yeah. All right. That's a good school.
Mm-hmm.
Hey, did you get that answer with the?
Yeah, that's what I was calling about.
All right. Well, let me get the. Let me find it real quick.
All right.
All right, here it is right here. So you know how to do, wow, that's pretty impressive. Now, did you figure this out yourself?
Yes.
Wow.
I did, yeah.
Alan, do you want to know the truth? I want to tell you something here. The truth is my first or second year of teaching, I cannot figure this out. It took me, matter of fact, I never did figure it out. So the fact that you could figure it out really ticks me off.
Oh, I hope I'm right then. I could be wrong.
But no, that's true. I had to ask the great J.T. Sutcliffe from St. Mark's to figure out how to do this. So what do I have to do?
All right. Well, it has to do with the C's. If you take the 1/2 natural log of 2x, and you separate it to the 1/2 natural log of x plus the 1/2 natural log of 2.
Right. This is algebra, baby. Right? It's algebra. Natural log of 2x. Natural log of AB is natural log of A plus natural log of B. Right?
Yeah. So it just becomes a constant, and
so it's equal to C. I'm sorry, plus C plus 1/2 natural log of 2. So that's just another constant, and it's the same answer, right?
Yep.
Man, you really did figure that out all by yourself?
Yeah. I told Miss Harmon, I said it has to do with the C's, and she just said, yeah, whatever. She kind of gave me that whatever it looks. And she said, oh, yeah.
That is impressive. I am impressed.
Oh, thanks.
Hey, about to cough. Great job.
All right.
Call in again. Annalisa?
Yep.
How you doing?
Fine. Did you miss me?
I did, as a matter of fact. I'm really glad you called in. So for that, you get a really good problem.
Do I?
Yes, you do. A fine problem.
Uh-huh.
It's hard to read.
Can you, get closer? Mr. Fleischer?
Okay. Can you read that okay? It says f of x is equal to e to the x over 3. Write the equation line tangent to f at x equals natural log of 8.
E to the x over 3. Okay, so y minus... Will you write that part right now?
Yes, ma'am. I will. I love it when you boss me around. Y minus.
And then leave a little blank spot.
A little blank spot, okay.
And then equals, and then another little blank spot.
All right.
Times x minus the natural log of 8.
Okay, that's good. I like the way way you're leaving your blanks.
Okay.
Because it's a live show.
Thanks. And then you need the slope, so you'll derive your f of x, and that's x over 3. No.
What's the slope? What's another word for slope?
Oh, derivative.
Go! Okay.
Okay. 1/3 e to the x over 3.
Right. It's 1/3 because this is the same thing as maybe easier to rewrite as e to the 1/3 x. It might be a little easier to do. So it's 1/3. That's the derivative. So at natural log of at natural log of 8, how do you find the slope? You plug in natural log of 8, but how do you simplify this baby?
You take the derivative of the power. Hold on.
Well, how do you find out e to the natural log of 8 divided by 3?
Hold on. I gotta think.
So do I. I'll give you a hint. This whole answer. You want me to tell you what the final answer is?
No.
Okay. Oh, good.
Well, okay, hold on. Yeah, could you just... Well, no, but then that's not...
I gotta give you one hint.
Okay.
I'm gonna rewrite this as e to the natural log of 2 cubed divided by 3. Because 8 is the same thing as 2 cubed.
Yeah, that makes sense.
Okay. So how can we simplify natural log of 2 cubed?
Bring the 3 to the front, and then they cancel out.
Right. So they cancel out. So we have 1/3 e to the natural log of 2. And what's e to the natural log of 2 equal to?
The e and the natural log cancel out.
Right. So this answer is just 1/3 times 2, or just 2/3. So that's our slope, is 2/3. And what about our y?
Hold on, I gotta erase. 2/3. So just plug in 2/3 to your original. No.
No, we plug in 2. That's the slope. Take your time.
What? Oh, yeah. Plug your x in.
Yeah, we plug the x into there, so we get e to the natural log of 8 divided by 3. And what does this simplify to again? Natural log of 8 divided by 3?
Hold on.
Okay.
2.
Yeah, it's 2. The 3's cancel out, so it's just e to the natural log of 2. So the whole answer is just 2.
Right.
That's a fine job. So that would be the answer.
Thanks.
Wasn't that fun?
Yeah.
I had fun.
Do you know what?
What?
I think that you're on a roll today.
I'm on a roll?
Yeah. You know, like all jumpity and stuff.
I'm all jumpity?
Mm-hmm.
I was just sick last week.
I didn't see you last week. I emailed you and told you I was going to be in North Carolina, didn't I?
Oh, yes, you did. I apologize. Sorry.
Okay.
All right. Well, thanks for telling me I'm on a roll. I appreciate that. All
Bye,
right.
Mr. Fly.
Go Cal. Rodrigo!
Yes.
What do you mean, yeah? A little enthusiasm. Rodrigo? Yes. Are you, say Jaguars.
Jaguars.
Rodrigo, what, are you trying to get a date or something? You know, what is do I have your picture, Rodrigo?
No.
I don't? Yeah, I think I have pictures of everybody.
No, you're crazy.
What's that? I'll find it in a second here. Hey, let me give you a problem.
Okay.
Okay, Rodrigo. All right, here you go. Here's a fun problem, sort of similar to the last one. What are we going to do, Rodrigo?
Okay, you need a point and a slope.
Very good. If you're going to write equation in line, you need a point and a slope, right?
Yeah.
Okay, so what do we have? What's given to us?
Okay, plug in 2e squared to the x. To
Okay,
y.
so to find the point, f of 2e squared is equal to natural log of 2e squared over 2, which is equal to what? How do you simplify that?
2.
It's equal to 2, right? Because this is the 2's cancel out, and you just have natural log of e squared, which is just equal to 2, right?
Yeah.
Okay, so from there, okay, so we got our point. We got our point, which is equal to 2e squared comma 2. How do we find our slope?
Take the derivative.
Derivative! So how do you do that?
It's a half over x squared.
Right. It's 1/2 over what?
X squared.
Well, it's 1/2 over. X over 2. Over it's the derivative of x over 2, which is 1/2 divided by u. It's a derivative of u all over u.
Yeah.
So it's 1/2. And how do you? What does that simplify to?
1 over x.
It simplifies to 1 over x, right? So that is the derivative is 1 over x. So at x equals 2e squared, the derivative would be equal to 1 over 2e squared. So you have a point. You have a point and a slope, so the answer would be y minus 2 is equal to 1 over 2e squared times x minus 2e squared, which would simplify to y minus 2 is equal to 1 over 2e squared x minus 1. And then you could add the 2 to both sides and you get plus 1. You sort of see that, Rodrigo? You see that? There it is, Rodrigo! What do you think about that, Rodrigo? Okay, hey, listen, call in again, Jaguars. Call in again. Hello?
Hello?
Will?
Yeah?
Will, what's your last name?
Brown?
Hey, Will Brown, how you doing?
Alright, how about you?
Pretty good. Who's your teacher?
Yeah, you're not gonna get my picture either.
I know. Who's your teacher?
Mr. Adaminas.
The great Mr. Hadaminas.
Yeah.
Hey, let's stick with these same type of problems, okay?
That's not okay.
These are fun. This one's a little bit harder, though. Okay, it's a little bit harder. A little less algebra, a little more calculus. Or maybe, I don't know, something like that.
The derivative of natural log of 4 over x is going to be...
Take your time. Be careful.
You take the derivative of what's inside and put it over 4 over x.
Okay, what's the derivative of what's inside?
Negative 4 over x.
What is it?
Negative 4 over x.
One more time.
Negative 4 over x. Negative 4 over x squared.
Right, because what's inside is this, right?
Right.
So the derivative is negative 4.
X to the negative.
So equal to negative 4 over x squared. So it's the derivative of that divided by that. Now, what does that simplify to?
Simplifies to negative 1 over x.
Yeah, negative 1 over x. And you know what's something interesting? You'll get the same derivative every time, no matter what this number. If this is a constant divided by x, the answer will always be negative 1 over x for the derivative, always. And you could practice with that to see that. So that's the derivative, so bring us home. Tell us how to do the problem.
You plug in 3. No, hold on. Derivative x equals 3. Yeah, plug in 3 for negative 1 over x. You get negative 1/3, which is the slope. And then you plug in for x in f of x, you get natural log of 4/3.
Right, so it's natural log of y minus natural log of 4/3 is equal to negative 1/3 times x minus 3, right?
Right.
Hey, that's a fine job, Will Brown. Fine job. Call in again, all right? Give me a picture of Mr. Adaminas.
No, that's okay.
All right. Who's out there? Hello?
Hi, I'm back.
Butters! Butters. You know, I got to get your real picture. Inquiring people want to know. All right, Butters, you get a tough problem here because you humiliated me last time with getting that so easily.
Don't do this to me.
No, this one's tough.
I'm having a headache. Come on.
All right, no, this one's tough. And you only have like 2 minutes, so.
Oh, find y in terms of t if when y equals 1 and t equals 0. How fun is that? We have to integrate, right?
Well, you tell me.
Okay, to find y, so we would have to integrate because that's a derivative, isn't it?
Yeah, that's right. It is a derivative. So if we want to get rid of the dy, want to get rid of the d, you'd integrate. Like if you want to get rid of division, you multiply. It's inverse. All right, good. So what do we do?
I guess integrate.
Yeah, you know what you're really doing? You're really multiplying both sides. Oh, wait a minute here. I don't know how did that work there. What you want me to just integrate 2y plus 3?
Maybe.
Whenever you have separable different, whenever you have something like this.
Oh, wait. First of all, put the dt over there to the other side.
So dy is equal 2y plus 3 times dt, okay?
Okay, now integrate.
Before you integrate, here's a little trick. You always have to have all the variables on one side of the equation.
Okay, I barely see it, but yeah. Okay.
So you'd want to divide both sides by that.
Oh,
first.
right. Y's on one side and the other one's on the other side.
Right. I know that. I know Miss Harmon showed you that.
Yeah. How about we integrate now?
Okay, now we integrate because all the variables are on one side of the equation. What's the integral of that?
Is that the natural log of 2y plus 3?
It's 1/2 because the 1/2 times natural log of 2y plus 3.
Yes. Yeah. Equals to, what is it, just dt?
What's the integral of dt?
Oh, t.
T, that's right. It's like the integral of 1, so it's 2 plus c.
Mm-hmm.
So how do we find y?
We need to find y in terms of t.
So we have y. We don't have. In other words, we need to have an answer that says y equals something.
Put a 2 on the other side first. The 1/2. Put it on the other side.
Well, how about if we just sub in first?
Oh yeah, to get c.
Yeah.
Okay.
How about 1/2 natural log of 5 is equal to c?
So that's natural log of 5 is a number. How about we find that number?
Equals t plus 1/2 natural log of 5.
Okay.
Okay. Now what? Now we got to solve for y. What do you do?
Put the 1/2 on the other side. So
multiply both sides by
2.
Multiply both sides by 2.
Yeah.
Equals 2t plus natural log of 5. What do we do now?
Now e to both of them. E to the natural log of blah blah, which is 2y plus 3, and then e to that over there.
Okay, that's all right. But I want to simplify this first.
Oh, you get what is that? E to the what? I can't see.
E to the 2t plus natural log of 5.
Okay. Is that e to the 2t and then times e to the natural log of 2?
Man.
Which is a 2?
It's a 5, but that's okay.
5. I can't see it. I'm sorry.
That's all right. That is unbelievable. So this is just 5.
Yeah.
So you have 2y plus 3 is equal to 5 e to the 2t.
Now, and then minus 3 and divide by 2.
Then you subtract 3 and divide by 2, right?
Yeah.
Butters!
What?
Excellent job. Hey, Butters?
Yeah?
Did you try the calculus question of the week? It was sort of messed up on the website.
Yeah, see, the first time I saw it was messed up, so it confused me.
But
so
I know, and we're sorry about that. That won't happen again. Okay. So what we're going to do is we're going to show you this. But we're not going to give it to the first person who gets it right because it's an unfair advantage to people who have computers in the room. So what we're going to do is everyone who gets it right, we're going to have a drawing to make sure the person gets a $10 prize. But it's correct now, so make sure you go to the website Take your time. It's a good question, even for you, Butters. Even
Okay.
for you, all right?
All right.
Hey, great job. Y'all have a great week. We'll see y'all next week. Bye.